Alright, so let's examine a couple quick parallel line problems before we get to some more interesting ones. Now, we have this nice problem in the diagram on the right. AB is parallel to CD, and AD is parallel to BC. So we usually signify parallel lines with a little arrow mark, just like that. And if angle A is 73 degrees, then what is the measure of angle C? Okay, well, we have a bunch of parallel lines, but it's kind of hard to determine a transversal, unless you consider the parallel lines themselves, or one of them at least, to be its own transversal. So, what I mean by that is, imagine if I were to just extend this line out like that, and perhaps let's just get rid of that. Extend some of these lines out so that it looks like one of our more traditional parallel line problems. Now, hopefully you don't get lost all up in there, because this is the one that was the 73 degree angle. 73 degrees. Now, what that means is if we have alternate interior angles, because we have two parallel lines, AB, DC, and a transversal AD, then that means this one is also 73 degrees. Then that means this angle at D, this one right there, would have to be 180 minus 73. Well, 180 minus 70 is 110. 110 minus 3 is 107. So now we know that that angle at D is 107 degrees. Now, let me clear up some of this stuff, all this craziness. And let's just imagine if we applied the same logic for, again, this is, I should have, this one right here, 107. 107. And let's just apply like the same logic we did before. Extend, extend, and we get another sort of parallel line setup, just like that, where we can do alternate interior. So with this one, and we'll get the same 107 degrees, but then 107, we'll have the same problem here. This angle, since 107 is this one, would have to be 180 minus 107, which ends up being 73. So it ends up being our original angle. Now, hopefully you get to the point where all these extra lines are really unnecessary, and you can just quickly tell, and I'm just gonna get rid of all this, quickly tell. Alright, you got some parallel lines. These ones, here, and here. You start with this 73 degrees. Alright, any angles that I know are immediately congruent with it? No. So therefore, if I'm assuming AD is my transversal, and AB and DC are my parallel lines, then this has to be supplementary. Because if it's not complementary, it's supplementary. Hence, I would get the 107. And then the same logic would travel you over to angle C. Oh, it's not going to be congruent with 107. Hence, it must be supplementary to get the 73 degrees. Hopefully you get to the point where you can see that real quick. You don't need to draw the extra diagrams. Just realize parallel lines, if they're not the same angle, then they must be supplementary. Anyway, now let's try a little bit more tricky, but not too bad. So, AD and CF intersect at point E, and AD is parallel to FG. We also have CEB equals 3 times AEB, and EFG equals 2 times the angle AEB as shown. Find the measure of CED in degrees. So, this is what I want right there, my X. And notice it's asking for something very specific, in degrees. So there should be some precise measure that I should get. What could that be? Well, AD, FG, parallel, which means that alternate interior angles are the same. Alternate interior. Those two angles must be the same. And even more interestingly is that these angles must be the same, because you could see that they're vertical, AEF and CED, or you could also realize that EFG is corresponding with CED. Hence, they must also be 2T. Now, what can I do from there? Well, I notice I have a straight angle all the way from here. And I have it all expressed in terms of T. Straight angles add up to 180. So let me just add up all the angles. So I have T plus 3T plus 2T. Well, 3 and 2 is 5, plus 1 is 6. 6T equals 180. Divide by 6, and you will get your answer of 30 degrees. That is what T is. Now, you don't want T, you want X, you want CED. So what that means is you must do 2 times 30. I don't know why it keeps doing that, but 2 times 30 gets you 60. And that is your answer.